Good day once again, class. So for today's lesson, we're going to talk about problem-solving strategies using the Polye's four steps process. Now, every time that we solve, we always follow a certain processes like what will be the first step, the second step, and so forth and so on. So this will guide us, class, when we solve word problems, regardless whether the problem involves by trial and error, or the problems is using algebraic manipulations, or the problem is simply a logical problem. So we have this four steps process that was developed by Polye. The first one is we have to understand the problem first. So the best way to start any problem is for us to write down any information, class, that's provided as you come to it. Because if you do not know what are the informations, definitely you would have a problem solving such problem, class. So if you read the problem slowly and carefully, then you write down the informations that you encounter in the problems, you will always at least have a start on the problem, as what we say. Now, if you cannot understand, class, by first reading, it's okay. Then you have to reread it again until such time you have a fully grasp of what is the problem all about. Then carefully you identify and write down what is we are asking for you to find in the problem. So this almost helps you now to devise a strategy once you were able now to identify the given data in the problem. Then the second step, once you were able now to understand the problem by writing all the necessary informations, then step number two now is for you to devise a plan so that you can solve the problem. This is where the problem solving is at least as much, we could say, as an art and as a science at the same time. So there are many ways for us to solve problems. So here, when we say devise a plan, then it's up to you what approach you're going to use in solving the problem. These are the common strategies, class, in solving the problems. One is making a list of possible outcomes, or you can just draw a diagram so that you can understand better what is being asked. Our favorite class is the trial and error, or you can also find a similar problem that you already know how to solve. In other words, you already encountered similar problems, then you can use that as your leverage class in solving also the current problems. You can also use arithmetic, algebra, or geometry, or any mathematical ideas that you already have or learned from your previous subjects or topics. So once you have your strategies in solving the problems, then the third step is for you to carry out what problem strategy or what strategies you are going to adopt to solve the problem. So after you've made a plan, you try it out, but sometimes it doesn't work, then try a different strategy. So there are many ways to attack the same problem, class. So just be persistent in solving a problem. Then the last step is very important as well, class, because this is where you're going to check your answer. So it's always a good idea to think about whether or not your answer is reasonable. You will be able to use math to check your answers and see if it is exactly correct or logically correct. So do not forget what you learned about the estimations, because sometimes, class, you are going to use estimations as a way to check your answers. That can be a big help in deciding if the answer is reasonable or not. Because sometimes, class, if the original problem you are asked for, let's say the unit is in terms of meters, however, the data you are given is in terms of centimeters. So you're using that, using centimeters, because the data are in terms of centimeters, only to find out that the problem being asked is in terms of meters. So even if you have a correct solution, but your answer is not of the same units that is being asked for, so you give an answer in centimeters, but what is being asked is in meters, so that makes your answer not reasonable. Okay, so these are the four steps, class, according to Polye. Now let's have this as a simple example, class. If you are asked what is the maximum number of pieces that a pizza can be cut into 4 straight cuts. So, of course, you can have lots of ways of doing this by experimentations if you want to. Now, of course, what we do is to understand the problem. So we need to cut the pizza with 4 straight cuts, and the result is a maximum number of pieces or slices. And even slices or pieces of pizza is a possibility. Okay, as long as you use 4 straight cuts. Okay, so typically, what we do is, of course, we can now devise a plan once we were able now to understand what is being asked. Then a diagram could be a possibility as your strategy, or coupled with a trial and error, maybe do. Okay, so both a diagram and a trial and error as our strategy. So what we do is, if we're going to cut first, so we always use now 1 cut, so we still have 3 more straight cuts. Then we notice that there are 2 slices. Okay, then we continue cutting again with this time, second time around. So when you cut again, so we're already using the second straight cut, then we can count the number of pieces. In this case, we have 4 pieces already. Then continue cutting on the third straight cut, then continue counting how many pieces of pizza. So we will be having 6 slices already. And of course, for the last cut, you already have 4 straight cuts. Then counting the number of slices, what you have is 8 pieces of slices. Now, this may be your final answer, class, but the question is, will this be your maximum number of slices? When you have 4 straight cuts, we can have 8 slices, okay, uniformly, or more or less they are of similar slices. But is this the maximum number of slices that you can have if you only have 4 straight cuts? So that's the question there, class. So is this the maximum number? Then by trial and error again, then you can recut again the same pizza. Okay. Then of course we have first cut, you have 2 slices. Then this time, class, you notice that the cutting now is of tangent, so it's no longer at the center, because you can make any possible cuts that you can have as long as there are straight lines. So still, if there are 2 cuts already, then we have 4 pieces, which is similar to our previous solutions. Then if you have your third straight cuts here, then you count the number of pizza, you notice, class, that there are 7. So we have different slices of pizza. Some are big, some are small. So if you're going to count, there are 7. 1, 2, 3, 4, 5, 6, 7. Then if you cut again, another here. So these are of tangent, class. Then there are already 4 straight cuts. Then if you're going to count, there will be 11, which is actually 3 more than the previous. If you're going to count the number of slices, okay? So it does not say naman, class, that the slices should be the same or should be of similar shapes. But here, you were able now to have 11 slices. And this would be an appropriate answer, class, or a reasonable answer compared to the previous solution. So you can see also a pattern here, that how did we get 4 pieces here? So 2 pieces plus 2 equals 4. Then 4 plus 3 is 7. So you can use this pattern. 7 plus 4 is 11. So if there will be 5 slices, then that will be now, of course, 11 plus 5 is 16, and so forth and so on. So here we already have our answer as 11, and that could be our maximum number of pizza. Then, of course, you check your answer. One of the nicest things about using trial and error, class, because the strategy is basically at the same time checking your answer. So you already know you found the best choice, which is 11 slices of pizza. Okay. So another example is, this one is a logical question. If yesterday's tomorrow is Wednesday, what day will it be after tomorrow's yesterday? So again, we do the 4 process, okay, steps of understand the problem. So when you say understand the problem, you go back again. So what do we mean by yesterday's tomorrow? And what do we mean by tomorrow's yesterday? So when we say yesterday's tomorrow, it means that it is today. Likewise, tomorrow's yesterday is also today. So once you have already your understanding of the problem, then you can devise a plan on how you're going to solve these questions. So of course, all you have to do, class, is you are going now to substitute the statements yesterday's tomorrow and tomorrow's yesterday by the statement today. So it would be easier now for us to answer. Now, if today is Wednesday, what day will it be after today? Then carry out the problem. So what we do now is, of course, we can already answer. So if today is Wednesday, what day will it be after today? Then you know that the answer is Thursday. And of course, for your checking the answer, so you can figure it logically, and it makes sense that the answer is Thursday. Okay, so sometimes, class, we have problems that does not involve mathematics or does not involve computations. Okay, but still we can apply this for steps process by Paul. Another example is the sum of the digits of a two-digit number is 7. If 9 is subtracted from the number, the answer will be the number with the digits reversed. So find the number. So understand the problem, class. We need to find a two-digit number whose digit has a sum of 7. And when the digit is subtracted by 9, the result is a digit in reverse. So you can think of a combinations, class, of two numbers that when you add, it will be equals to 7, like 1 plus 6, 2 plus 5, 3 plus 4, then it's reverse, 4 plus 3, 5 plus 2, 6 plus 1, including 7 plus 0. Again, the sum is still 7. So do you have those possibilities, class? So listing will be used here if you want to. Then at the same time, as long as the total is 7, then if you're going now to subtract it by 9, then the result is the reverse of the digits. Okay, so that's the one that we are going to find out. So once you understand the problem, then devise a plan. Of course, by trial and error or by listings, we can do that. So we're using a trial and error. So what we do here is that you can now carry out the plan. So I will be having my first trial 61 because I know that 6 plus 1 is 7. If I'm going to subtract 61 by 9, the result is 52, which is not the reverse of 61, which is 16. So supposedly it should be 16 because it's the reverse of the 61. So the first trial is not a possible answer. Then I have 52. So again, 5 plus 2 is 7. 52 minus 9 is 43. And of course, the reverse of 52 should be 25. Here we have 43, which is not correct. Then third trial, 43 is our third trial. 4 plus 3 is 7. Then 43 minus 9 is 34. Now here we already know that the reverse of 43 is 34 if we subtract 9 from 43. So there we go. We already find our answer by trial and error. So by trial and error, the strategy, as I said, basically is checking your answer because at the same time, because we are using trial and error, class, so we can also already see whether or not our solution is correct. So that's how we use the trial and error. Now, you can also solve the same problem, class, using algebraic expression, which is very, very tedious, and sometimes it needs a lot of logical thinking here. So this can be solved algebraically. Let xy be the digits so that your x is the tens digit, your y is the ones digit. Then if you're going to rewrite your two-digit numbers in an algebraic way, that will be 10 times x plus y. And when you add x plus y digits, the result is 7. Then if I'm going to subtract 10x plus y as my two-digit number by 9, it will be the reverse. It becomes 10y plus x. So the x and the y uh, in the position will be changed, class. So I know that the other equation is x plus y equals to 7. Then I can isolate the variable x or the variable y. So I will be isolating the variable x so that x is equals to 7 minus y. Then I will be substituting 7 minus y into the x here. Because remember, 10x, sabi niya. Okay? So 10 times instead of x, I will be substituting it by 7 minus y plus y minus y is the same as 10y plus, again here your x will be substituted by 7 minus y. Then, of course, if you're going now to simplify this further, 10 times 7 is 70, 10 times negative y is negative 10y, plus y minus 9 equals to 10y plus 7 minus y. So combining all similar terms, so here I will be having 70 minus 9 is 61. Negative 10y plus y is negative 9y. On the right side, 10y minus y is 9y plus 7. So if I'm going to transpose negative 9y to the other side, then positive 7 on the other side, so I will be having 61 minus 7 equals now to 9y plus 9y. Then, combining again, 61 minus 7 is 54, is equals to 18y. Then what we do is we're going to divide it, both sides of the equations, by 18, so that 18y divided by 18 is y, then 54 divided by 18 is equals to 3. So therefore, y is 3. So if y is 3, what is x? So we know that x is 7 minus y. So we have 7 minus 3 is 4. So if you're going now to put this xy here, then you will notice that x is 3. Sorry, x is 4 and y is 3. Then you already have your 43. So that's the same class, only this is algebraic solution. Another example of a problem class is this one. So this is based on inequalities, okay? Now, Berta shipped some packages for her boss and cannot find the receipt, but she needs an itemized list to get reimbursed of how much did she spend in spending those packages to her boss. So here is what she remembers. There were 12 packages in total. Split them small flat rate boxes, which is 250 pesos each, and a medium flat rate boxes that is worth 525 pesos each. The total cost was the word about 5,500. Then how many of each type did she ship? Now, when we say about 5,500 class, it does not mean that it is exactly equals to 55. It could be less than or equals to 5,500. So we have to analyze our problem here. So understand the problem. Accordingly, there were 12 packages in total. And this comprises now small boxes and medium boxes with the following price or costs. So if you're going to add, the small number of boxes plus the medium number of boxes should be equals to 12. And the total should be about 5,500. So this means that the total cost, as I said, is not exactly 55, but less than or equals to 55, but not more than 55. Okay, so these are our understanding of the data. Then, how are we going to solve this problem? So, the easiest is trial and error. If you are fun using this one, it's okay. Listing and at the same time, because we are going to list the possible solutions. So if you're going to carry out your plan, so I will be having here the small box, the medium box, then the total. The small box is 250, the medium box is 525, and if you're going now to combine, okay, by multiplying the price or the cost by the number of boxes, remember class that the total should be 12. There are 12 boxes all in all. So the first trial is I will be having only one small box but 11 medium boxes. Of course, if you multiply this with its costs, and the total is 6,026, which is over the 5,500. So this is not a solution. Trial number 2, so by pattern class, so I will be increasing the small boxes, decreasing the medium boxes by 1. Then multiply again by its costs. And here, the total is 5,750, again, which is beyond the 5,500 total. Then we continue again subtracting. So what about 3 small boxes and 9 medium boxes? Then if we multiply this number of boxes by its costs, and the result is 5,475, which is less than 55, but it is not exactly 55. So it could be a possible solution because 5,475 is less than or equals to 55. So if you continue using the fourth one, 4 small boxes, 8 medium boxes. So again, the total is 12. We notice, class, that it is decreasing by a certain amount. Medyo malayo na siya, class, sa 5, 5. So we can stop here because we already have our plausible solutions. We have now the 3 small boxes and the 9 medium boxes compared to 4 small boxes and 8 medium boxes. So these are possible answers, class, but what is the closest to 5, 5 is the 5,475. So this one here is nearer to the 5, 5 as our solution. So thus the logical answer now will be 3 small boxes and 9 medium boxes. So that will be our solution, class. Of course, because this is trial and error, so we don't have anymore to use any substitution. Now, if you want to use algebraic manipulation, class, or algebraic solutions, this will give us 2 equations and 2 unknowns. One will be, okay, the total number of boxes, how many small, how many mediums. The second one is if we add all the costs, it will be less than or equals to 5,500. So the number, your x will be the number of small boxes, your y will be the number of medium boxes. So my first equation would be x plus y is 12 because there is a total of 12 boxes. The second equation is that we multiply the number of small boxes by its costs plus the cost of the medium boxes multiplied by its total number should be less than or equals to 5, 5. Okay. But first, because you might be confused of the less than or equals to, you just change this to equal sign so that it would be easier for us now to solve. Okay. So if we do that half, then looking back at the first equations, I know that the total is 12. But in terms of the other variables, so I will be isolating the small box as your x is equals now to 12 minus y. Then this is the one that I need to substitute into equation number 2. Okay, so instead of x here, I will be substituting it by 12 minus y. So what we are solving here, class, is the y, which is the number of medium box. Okay, so we simplify. 250 times 12 is 3,000. 250 times negative y is negative 250y. Plus 525y equals to 55. Then combine similar terms. Okay, then we have here now the negative 250y from the right side. Then the 3,000 from the left side will be moved to the right side, becomes negative 3,000. Then simplify again by combining. Then negative 250 plus 525 will be 275. Of course, the common y variable, 55 minus 3,000 is 25. Then I can divide both sides by 275 so that I can isolate the variable y. So of course, 25 divided by 275 is 9.09. But we are talking, class, about the number of boxes. So we cannot have 0.09. So we just use the rounding off. So 9.09, this will be rounded to a whole number, will be the same as 9. So now I already have that there should be 9 medium boxes. So if there are 9 medium boxes, because I know that the total is 12, then definitely I can solve for the variable x. So x is equals to 12 minus 9. then x is equals to 3, which is now 3 small boxes. So which is the same doon sa previous solutions natin by trial and error class. So now we must test whether or not if we multiply this by the costs of shipments, it should be less than or equal to 55. So 250 times 3 plus 525 times 9, it should be less than or equals to 55. And yes, it is less than or equals to 55. So there we go. So still, the answer is the same class. Only that the way that we devise the plan to the solutions is much different. It's more of an algebraic solution class. So medyo ano siya class, longer and takes lots of manipulations algebraically as we say it. For number 5, so if you are asked to arrange the digits 1, 2, and 3 to form a 2-digit number or a 3-digit numbers, but it is divisible by 6. Now, no repetition of digit is allowed. So, understand the problem. We are going to form a 2-digit number or a 3-digit number where no repetitions are allowed using only 1, 2, and 3 so that it will be divisible by 6. Okay, so how are we going to do this? So what will be our device to plan and solve this problem? So of course, the easiest is by trial and error. Now, I can form 2-digit number like 12, 13, 23, 31, 32. When it comes to a 3-digit number, I could have 123, 213, 231, 132, 312, 321, and so forth and so on. Okay, so maraming possibilities class. Okay, so by trial and error, so I will be using 1 and 2. 12 divided by 6 is 2. 3-digit number, 1, 2, 3 divided by 6 is 20.5. Then, if I'm going to exhaust all of these possibilities class, these are the 3 or the 6 different ways of using 2-digit numbers out of 1, 2, 3. Then I'm going to start dividing it by 6. Then, of course, what will I look is a number that is a whole number, because when you divide it by 6 and if the number is a whole number, it means that it is divisible by 6. So here I only have 1, but among the 3-digit numbers, these are the possible combinations. Okay, so 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, 3, 2, 1. Then I start dividing it by 6. Then look for the whole numbers as the results, and that would be our solutions. And by, of course, trial and error, we already have the 3 possible solutions. So carry out the plan, of course, because this is our trial and error. Then we found out that 12, 132, and 312 are the only digits which are divisible by 6. Okay, so this is how we solve also. Now you can check your answer, but since it's a trial and error, as I said, this strategy is already itself checking your answer. Okay, pag naka-trial and error class. Because along the way, the process of the trial and error, you are also checking whether or not your solution is correct. Yan. Now, another approach to the same problem class is to use definitions, use principles, okay? Now, I will be using divisibility rule as my way of finding out. So, we have these 3 rules. A number is divisible by 6 if the digit is both divisible by 2 and 3. A number is divisible by 2 if the last digit is even. A number is divisible by 3 if the sum of the digit is divisible by 3. So if I'm going to apply this class to each of the combination, then we can carry out the plan. So like for example, 12. So the last or the ones digit class is 2, which is even number. So I know that this is divisible by 2. Then if I'm going to add the digits, 1 plus 2 is equals to 3. Then I know that 3 is divisible by 3, so it satisfies these conditions. Therefore, because it's divisible by 2 and it's divisible by 3 at the same time, then 12 is also divisible by 6. So by this definition. So a number is divisible by 6 if it's divisible by 2 and divisible by 3. So 12 is divisible by 2, 12 is also divisible by 3, therefore this is divisible by 6. So we continue exhausting all the possibilities. Now, first is that because accordingly, so that you can only choose, okay, from the 12 possible, then you just choose only those digits that ends with an even number because those are the digits that are divisible by 2. So, if you have here 13, you know that 13 is not divisible by 2, so hindi na siya pwede. So, only those ending with 2 will be subject for testing. So, I already have the 12. Then 32 again, I can divide 32 by 2, but if I'm going to add 3 plus 2, the result is 5, and you know that 5 is not divisible by 3. 132, I can divide 132 by 2 by its rule because it ends with an even number. But if I'm going to add 1 plus 3 plus 2 is 6, and 6 is divisible by 3. 312, 312 is divisible by 2, check. And if I'm going to add again 3 plus 1 plus 2, the sum is 6, and 6 is divisible by 3. So among these four possibilities, class, all of these are divisible by 2. But these four, only 3 are divisible by 3. So we only have 12, the 132, and the 312 are divisible by 3. So only these 3 are to be considered, class, because they are both divisible by 2 and divisible by 3, and therefore they are also divisible by 6. So that will be our answer, class, which is the same using the trial and error. So we have 12, 132, and 312. Okay. So here you have to check your answer. Definitely, you can always divide 12 by 6. You can divide 132 by 6. You can divide 312 by 6, and it will give us a whole number value. So therefore, 12, 132, and 312 are the digits that are divisible by 6. So this is an alternative solution, class. So if you want to use the concept or the definitions of divisibility rules, you can apply this one. But as I said, we are fond of using the trial and error, which is actually accepted naman, class. Okay.